Hi everyone, good day. Today we are going to see lecture number 4 in the series of the course Cryptography and Network Security. So in this lecture, we are going to cover the topic mathematics of cryptography. Why we need to learn mathematics in the case of cryptography is, so in cryptography, we are going to apply or many mathematical operations. We are going to do many mathematical operations. For example, if you consider a algorithm called as RSA algorithm that we are going to discuss in asymmetric cryptography, there we need to consider two large prime numbers. So if you want to check whether the two large numbers that we are considered prime or not, we need to follow one algorithm which derives primeness of the given number. Like that, after doing that one, we need to know about modulus operations. We need to know about modulus operations. So we need to know about modulus operations. We need to know some basic mathematics. Similarly, we'll also use some elliptic curve algorithms in this cryptography. There we need to know about elliptic curve. What is elliptic curve? What is the equation that we need to represent elliptic? Like that, we need always cryptography is also submerged or interrelated with the mathematics. But in this first unit, we are going to learn about basic mathematics regarding cryptography. In the second unit, we are going to learn about what are the mathematics that are required for the symmetric algorithms. Like there, we are going to learn about group, field, finite fields, rings, and about polynomials. Whereas in the third unit, that is in the asymmetric cryptography, we need to know about mathematics that is required for asymmetric cryptography, like what are the prime numbers. If you've given a number, what is the process to check whether the given number is prime or not. Similarly, we are going to have Euler's theorem, Little's theorem, like Chinese remainder theorem. Like these will have logarithmics. Like this will have many things. But here in the first unit, we'll just learn about basic mathematics that are required for the cryptography. So we'll start with integer arithmetic. So in integer arithmetic, we are going to see about what is the set of integers and what are different binary operations that we are going to apply on the set of integers. So to start with set of integers are going to be represented by using the word letter Z, So which are considered to be set of integers? So the values which are lying between minus infinity to plus infinity. If you have set of values which are lying between minus infinity and plus infinity, now we can consider all those values. There will be set of integers. All those values will be set of integers. Now, on these set of integers, we can apply different operations like unary operations or binary operations. But here in the case of cryptography, we only consider about binary operations. So, which operations are considered to be binary operations is if you have two operands. If you are doing any operation between two operands, then we can consider that operations as binary operations. Like if you are doing addition between two numbers, subtraction between two numbers, multiplication between two numbers, all these operations can be considered as binary operations. Similarly, we can also have unary operations that we have seen in our C language, that is decrement operator and increment operator. Why we are calling them as unary operators is here we have only one operand. Here also we have only one operand. So by the type of the operation depends upon how many number of operands we are using, or between how many operands the operation is being done. Okay, so in the binary operations, we are going to see about addition, subtraction, multiplication, and division operation. Right? In cryptography, we are interested in three binary operations applied on the set of integers. So I told you, some addition, subtraction, multiplication, and division also have more importance in cryptography. Like first, we will see about addition, subtraction, multiplication, and then we'll move to division. Why? Because I'll tell you. So if you consider these three operations, that is addition, subtraction, and multiplication, whatever the operation that you apply, any of the three, the input that you are taking is from the set of integers. That is, the two operands that we are consider are from the set of integers, and the resulting, whatever the result we are getting, that is also will be within the set. That is also will be within the set of integers only. That will also be within the set of integers only. So if you observe here, we are taking the operand A from set of integers, Similarly, we are taking operand B from set of integers. If you apply any one of these operations, we'll have a single output. And that output will be belonging to set of integers. So we have some examples for addition operation, subtraction operation, and multiplication operation. So if you consider, if you add two positive numbers, then the resultant value also belongs to the set of integers. If you add one negative and one positive numbers, the resulting will also be in the set of integers. If you're going to apply addition operation between two negative numbers, there also the resultant will be belonging to the set of integers. Right? Similarly, for the subtraction also, see, if you observe the subtraction result, what we are getting, it also belongs to the set of integers. Similarly with the multiplication, so even if you get large number of value, that will be less than plus positive only. That will be less than plus infinity only, right? Plus infinity only. So it belongs to set of integers only. That's why we consider these three operations belong to one set, because if we go for a division, we'll see later why we are not considering division here, why we are considering these three only. Why? Because these three will give you only one output. If you do a binary operation between two operands, they'll give only one output. But whereas in the division, we'll get, if you do apply division operation between two operands, we'll get two outputs. One will be coefficient and the other one will be remainder. That's why we are not considering the division operation within this class of operations. Why? Because these three operations, that is addition, subtraction, and multiplication, if you apply these operations between two operands, the resulting will be only one value, and the value will be in the set of integers. But in integers division, we'll get how many outputs? We'll get two outputs. One is coefficient and the other one is remainder. That's why we are taking it as another class. Okay, so I think we are clear with addition, subtraction, multiplication. See, we are learning from our childhood. It will be clear to you. Now we'll see about integer division. Now consider if you are having two values, a and n. If you are having two values, a and n. Now if you are applying a division operation between a and n, then we will be getting two outputs, q and r. We'll be getting two outputs, q and r. So in this scenario, we call a as dividend. A as what? Dividend. And we call that n as what? Divisor. And q is what? The coefficient we get, and r is the remainder. So we can represent here a as a equal to q into n plus r. We can consider a as what? Q into n plus r. Okay. Now if you represent, we'll see one example for this one. Now we're going to see how whenever you are given a value, how we are going to get the values, right? So if we consume that a is equal to 255 and n is equal to 11, now let us find out how we are going to get the values for this one, right? So we are going to have 255 here. Consider we are going to have 255. And what is the divisor that we need to consider? The divisor is 11. The divisor is what? 11. Now, if I consider 11 as divisor, now I can take 2 times 2 of 11. It will be 22. Now, if I subtract it, it will be 35. Now I can take it 3 times. Now it will be 33. So we're getting 2. Now this 2 will not be get divisible by 11. So this will be as a remainder, and this is the coefficient. Okay. Now in this case, our n is our a is 255, which is being getting divided, and n is equal to 11. We call it as divisor. The value we got here, we call it as coefficient. We can represent by using q, and the value which is not divisible by the divisor finally is called as remainder. So if you observe here, I can represent 255 equal to I can represent 255 is equal to q into n. That is, q is what here? 23 into 11. 23 into 11 plus remainder is what? 2. So if you consider this one, 23 into 11 will be 253. Will be 253, and the value we are going to add is plus 2, so which is equal to 255. This is how the division operation occurs, and we can represent the divisor as coefficient into, sorry, we can represent a dividend as coefficient into divisor plus remainder. Now, if you observe the same way, if you're considering, we will take a from the set of integers. Here we will take the set of integers and we'll take n as a positive value. Remember, we should always take n as a positive value and we'll take r as a non-negative value. So we are saying positive and non-negative. We are saying positive and non-negative. What is the difference between positive and non-negative? What is the difference between positive and non-negative? So all the values that are starting, from 1 to plus infinity, all the numbers that are starting from 1 to plus 1 to plus infinity, they all are considered as positive values or positive integers, and the values starting from 0 to plus infinity, we call them as non-negative number. The difference is only what? 0. Here in positive values it doesn't consider 0. In non-negative values we consider 0. Why? Because if I consider here n as a non-negative number, now it will become, we can consider also 0. So anything by 0 will not, anything by 0 is what? Infinity. Right? Anything by 0, it doesn't get a good value. That's why, so we doesn't consider it as a non-negative number. We consider it as a positive number. And these two are the assumptions that we should have while we are dealing with division operation, while we are dealing with division operation. Okay, so if you observe here, we are taking the dividend from the set of integers, and we are applying the division operation, and finally we are getting the coefficient which belongs to set of integers, but this belongs to set of integers only, but we consider it as non-negative. Why? Because if I take z here, I'll get negative values also. So that's why I'm not taking n and r into the set of integers. That's why I'm considering r as non-negative value and n as positive value. Okay, I hope you understand the division operation. Now we can also have two definitions here. We also have two definitions here in the division operation. In the division operation, if we consider a is being divided by n, and if r equal to 0, consider if r equal to 0, then what I can say is a exactly divides n. A exactly divides n. That is represented by a line n. That is n exactly divides a. N exactly divides a. Okay. Similarly, if the remainder is not equal to 0, then I represent this as what? A not exactly divisible by n. A is not exactly divisible by n.